Everyone's beloved space probes, the Voyagers, are once again making headlines. Recently, it appeared that we nearly lost contact with Voyager 1 permanently. On December 12, 2023, NASA announced that Voyager 1's flight data system, which comprises 3 onboard computers, began transmitting binary gibberish data back to Earth, a repetitive sequence of ones and zeros that was indecipherable to the engineers. When the anomaly first happened, engineers could still send signals to the remote probe and confirmed it was still functioning, but something was evidently wrong. The first solution NASA attempted was restarting the system, but that was ineffective, and the probe continued to transmit nonsense. After months of trying every possible method, NASA engineers eventually devised a resolution. We'll discuss that shortly, but first, let's delve deeper into the Voyager 1 probe to understand how impressive it was for the engineering team to find a solution to the glitch in the first place. Firstly, it's remarkable that the Voyager 1 and 2 probes have been traversing space for nearly 47 years, and NASA has been doing everything possible to maintain their functionality, not only to extract as much data about interstellar space as possible, but also hoping they will still be operational for their 50th anniversary in space. Voyager 2 was launched first on August 20, 1977, and Voyager 1 on September 5, 1977, making them the oldest active space probes. One of the most astonishing aspects of the Voyager probes is that they were initially designed to last just 4 years. When Voyager 1's communication issue first emerged, NASA engineers feared it might be the end of contact with Voyager 1, describing it as a very stressful situation. We certainly don't want to lose contact with the probe after all it has achieved and endured. Voyager 1 is a highly significant spacecraft that has accomplished some very extraordinary feats. It is a scientific icon, to say the least. It revealed that one of Jupiter's moons, Io, was not just a lifeless rock but a supervolcanic planet. This color-enhanced image of a volcano on the moon erupting into space was so astounding it left everyone in awe and was a major surprise for NASA scientists. Additionally, this stunning image of Saturn that Voyager 1 captured amazed everyone. Not only were the images stunning, but the probe also discovered that Saturn's largest moon, Titan, might actually have liquid water on its surface. These are just a few of the discoveries made by the probe. So, what happened to Voyager 1 and what caused the spacecraft to stop communicating normally? Turns out that a crucial system had malfunctioned. Voyager 1's flight data system is a vital component that enables the spacecraft to operate autonomously during its deep space journey, and currently, the probe is an incredible 15.5 billion miles away from Earth. The fact that we can still communicate with the probe is an amazing achievement, but there's a mind-blowing reason for this that not many people know, and we'll reveal that in a few moments. But first, back to the glitch. The flight data system of Voyager 1 is composed of various elements working together to oversee the spacecraft's operations. This includes the central computer, data storage units, command interface, and telemetry systems. The primary computer aboard Voyager 1 is the Command and Data Subsystem, CDS, which processes commands sent from Earth and manages the spacecraft's functions. In case you're not familiar with the computers aboard the Voyagers, here's a comparison. Voyager 1's computer system is very rudimentary by modern standards. The Command and Data Subsystem has only 68 kilobytes of memory and a processing speed of merely 88 kilohertz, which is about 8,000 instructions or cycles per second. To illustrate just how basic that is, a contemporary central processing unit with a clock speed of 3 gigahertz performs 3 billion cycles per second, and most smartphones today have 32 gigabytes of memory. In contrast, the difference in storage is like having a cup with 68 drops of water compared to 32 Olympic-sized swimming pools full of water. The issue with the glitch occurred in the flight data system, which is a crucial part of the spacecraft's overall structure, responsible for managing and processing data collected during its mission. The primary function of the flight data system is to collect, process, and transmit scientific data gathered by Voyager 1's instruments and experiments back to Earth. You could view it as the central nervous system of the spacecraft, coordinating its various subsystems and ensuring smooth operation throughout its journey. After months of attempting to determine what was wrong, engineers at NASA discovered that approximately 3% of the flight data system's memory was corrupted. It's possible that the malfunction was caused by charged particles in deep space or simply due to age. Naturally, mission engineers couldn't repair the chip, So they divided the corrupted code on the failed chip into segments that they could store in spare areas of the FDS's memory. The first fix was sent to the Voyager 1 probe on April 18th, with a total of 30 billion miles to cover from Earth to the spacecraft and back. The NASA team had to wait nearly 2 full days to get a response from the probe, but on April 20th, 2024, and with great relief, NASA received a reply from the probe that the fix had worked. Now, engineers will need to rewrite the remainder of the flight data system's lost code in the coming weeks. This will include commands that will restore the probe's ability to transmit more crucial scientific data. This isn't the first time the probes have encountered failures. The long years in the harsh environment of space have been tough on Voyager 1 and 2. Contact with Voyager 2 was lost in August 2023, and engineers thought that would be the last time we would hear from it. But just a few days later, communication was reestablished. Because the spacecraft have been in space for such an extended period, NASA engineers have had to shut down some of the probe's systems. Voyager 1 currently has 4 out of 10 instruments operational, and Voyager 2 has 5 of 10 still functioning. To conserve power on the probes, NASA engineers have turned off heaters and other systems to save energy for the high-gain antennas, which are the probe's main communication points with Earth. The other instruments that are still active include the magnetometers and low-field magnetometer, which measure the magnetic fields of the Sun and outer planets. One significant discovery from this instrument occurred in 2015 when the spacecraft found that even beyond the heliopause, which is the outer boundary of the heliosphere that acts as the surface of the bubble surrounding our solar system, solar winds can still redirect the magnetic field of charged particles they encounter. The low-energy charged particle instruments are still operational on both probes. It was this instrument that helped researchers locate the heliopause in 1993, after a violent burst of solar activity from the Sun. Hydrazine thrusters are still functioning on both spacecraft, propelling the probes and helping them stay warm. Both space probes have a micrometeorite shield that protects the instruments at the rear of the spacecraft from dust and tiny particles. The other important instruments still powered include the optical calibration target instruments, which calibrate each of the probe's charged particle instruments. Both Voyagers have had their instruments pointed at the target plate for calibration countless times during their extensive deep space travels. Other instruments on the probes are turned off, and some have been off for decades to conserve power. Aside from the instruments, the probes have radioisotope thermoelectric generators. These generators use plutonium-238 to power the spacecraft and keep them warm, extending their missions for such a long time. However, they are beginning to weaken, and one day will cease operating altogether, ending the missions forever. That day could arrive soon, but even when the probes eventually go silent, they will still hold value for us. Let's not forget that both spacecraft carry a message from Earth for other advanced civilizations that might exist and could potentially detect these probes in space. The Voyager Golden Records are phonograph records placed aboard both Voyager spacecraft. These records were designed to provide a snapshot of Earth and its inhabitants for any extraterrestrial intelligence that might encounter the probes in the far future. The records include recordings of various natural sounds from Earth, such as thunder, bird songs, and the sound of ocean waves. They also contain greetings spoken in 55 languages and musical selections from different cultures worldwide. Some of the musical pieces include Bach's Brandenburg Concerto No. 2, Beethoven's Symphony No. 5, and, believe it or not, Chuck Berry's Johnny B. Good. The records also feature 16 images encoded in analog form, illustrating various aspects of life on Earth, including landscapes, animals, human anatomy, and scientific diagrams. It's noteworthy that the content was curated by a committee led by the late, great Carl Sagan, the astronomer, cosmologist, and science communicator. The records are made of gold-plated copper and are designed to withstand the rigors of space travel for billions of years. Each record is enclosed in an aluminum cover with playback instructions engraved on the outside, including information on how to construct a stylus and a cartridge to play the records, as well as a diagram showing the location of the Sun relative to 14 pulsars, which can be used to determine the time and place of origin of the spacecraft. Yes, if there are hostile aliens out there, we just provided them with directions to our planet. They might not be concerned that the primary purpose of the Golden Records is to convey a message of goodwill from humanity to any extraterrestrial beings that might intercept the Voyager probes. Well, Let's hope that doesn't happen anytime soon. Now, remember when we mentioned that we had something astonishing to share? It relates to the amazing fact that we're still able to communicate with the probes at all. With both being over 15 billion miles away, Voyager 1 is moving away from us at about 38,000 miles per hour, and Voyager 2 is traveling at about 35,000 miles per hour. But here's something intriguing that you might not have known. For a portion of every year, Earth orbits around the Sun and moves towards both spacecraft faster than they are moving away. That's right, Earth, in its orbit, approaches the spacecraft at a speed of 67,000 miles per hour. Therefore, their distance from Earth temporarily decreases. They never alter their outward motion. It is us and the Earth that changes. Both Voyager probes continue their mission to explore interstellar space and send valuable scientific data back to Earth. They remain the farthest human-made objects from Earth, operating beyond the influence of our Sun's solar wind in the interstellar medium. They are truly a testament to the ingenuity of human imagination. That's all we have for today, but be sure to stay tuned here for more updates on the Voyagers as we receive them. Let us know if you want to hear more about the discoveries from these incredible probes in the comments, and thanks for watching.